rational expressions. Here are the rules to follow for dividing rational expressions. You've already been taught how to multiply rational expressions, so the only difference with division is if you get a division of rational expressions, you want to change the division symbol to multiplication and then reciprocate. What reciprocate means is going to flip that fraction from numerator to denominator to vice versa. Then the rest of the problem is the same. You factor, cancel, and then clean it up. So here's our first example. I started off with a couple easier ones without any variables in it. So we have 6/8 divided by 12/32. So we're going to keep the 6/8 as it is. Then we're going to change that division symbol to multiplication. And then we're going to change that second fraction. We're going to flip it or reciprocate it. So now it's 32/12. Now we're set to go. We can go ahead and reduce. So I'm going to reduce the numerator and denominator of the 6 and the 12 by 6. So I have 1 and a 2. Then I'm going to reduce the 8 and the 32 by 8. So this becomes a 1 and a 4. Multiply across, we get 4/2, which is 2. Second example, the division symbol looks just a little bit different. It looks like a fraction bar, which is totally fine. So this is your first fraction. It stays as it is, 36/45. We're going to change this division symbol right here to multiplication. And then we're going to flip this second fraction. We're going to reciprocate it. So it's going to now be 27/16. Now we can reduce. So we look at the common factors. 45 can reduce by 9 to 5. 27 can also reduce by 9. And we're left with 3. Now we look at 36 and 16. You can reduce that by 4. So you could take 4 here, and you can reduce this, and you get a 9. So multiply across, and you get 27/20. All right, now let's go on to a couple of more challenging problems. So now we are going to throw the rational expressions, these things that have those variables in it. So let's look at the first fraction. That stays as it is, x² minus 36/x. We're going to change that division symbol to multiplication. And then we're going to flip this second fraction. So now it's going to be x² plus x over x³ minus 6x². Now we're going to clean it up by factoring. So this first piece can be factored using the difference of two squares, x minus 6 over x plus 6. This can just stay as it is, so that's just an x. We have our multiplication symbol. We come up to the numerator. The numerator has a GCF, so I can pull out an x. I'm left with x plus 1. In the denominator, I can take out an x², a GCF. X², and I'm left with x minus 6. So now everything has been factored. Now let's see what can cancel. What are the common factors that can make it to cancel? So one of the factors could be x minus 6. So x minus 6 and x minus 6 cancel. Then I can take an x and an x out. No other common factors. So now what I'm left with in the numerator is x plus 6 and x plus 1. In the denominator, I have x². Last example, we're going to keep the first fraction, x minus 4, over x minus 2, all squared. Change the division symbol to multiplication. And now this second fraction, I'm going to flip it. x² minus 4, x² minus 3x minus 4. Now, before we do any canceling, we have to factor first. So the first fraction's numerator in the red, the numerator just stays as x minus 4, but the denominator I can change to x minus 2 and x minus 2 because there's two of them. Now we're going to head up to the numerator in the second fraction. That can change to factoring by difference of 2 squared, so x minus 2, x plus 2, and the denominator is your T-chart method. What are the factors of negative 4 that add to negative 3? Well, that is negative 4 and positive 1. Now we have it completely factorized. We're going to look for common factors that can cancel. I have an x minus 2 and an x minus 2 that can cancel. An x minus 4 and an x minus 4 that cancels. So we're left with in the numerator x plus 2. In the denominator, we're left with x minus 2 and x plus 1.